Hi everybody. So in this video we are going to work with general rate functions. So we've already talked a little bit about working with position, velocity, and acceleration, which are specific types of rate functions. Now we're going to look at rates that are not necessarily velocities. They're just rates that are describing something else. So a lot of the problems we're going to look at are going to be read this way. And what I'd like to do is start by reading through here and just picking out the important information that's going to be given in most of these problems. So it says here the rate at which people enter an amusement park is modeled by the function e. So I can already tell this is going to be a problem about rates because it says in the directions the rate at which people enter is here. I can also tell this is going to be a function about rates because then it immediately says the rate at which people leave is given here by L of t. Both E and L are measured in people per hour, and T is measured in hours after midnight. So they're defining our units for us. And the functions are valid between 9 and 23, which are the hours during which the park is open. Finally, and they're going to give you this information, and it's really important that you watch for it. They tell us that at t equals 9, there were 10 people in the park. This right here is an initial value. They're giving us an initial piece of information. So at t equals 9, at the beginning of what they said we could do, there were 10 people in the park. So what information are we given? We are given there's a rate coming in. We are given the rate that's going out. We are given the units. And we are given an initial value. Now it's really important. I'm going to use orange because I'm afraid my yellow isn't showing up very well. It's really important that you identify the initial value that you are given because you're going to need that later on in this question for sure. So let's just start by talking about some things we could calculate using this information. In this scenario, if you were to integrate from 0 to 14, what are you finding? Now this is actually a typo and I apologize. This should actually say 9 to 14. Just like this one should say 9 to 14. And the reason is because these functions are only valid between 9 and 23 hours. Okay, so in this scenario, if you calculate the integral from 9, I'm sorry, you can't see that I even just wrote that in, I apologize. From 9 to 14 of e of t, what are you finding? Well, when we integrate a rate function, what we're doing is we're finding the area. So if we were finding the area, in a graph where the y values are measured in people per hour and the x values are measured in hours after midnight, then the area would be people per hour times hours. So we're really just counting the people. In other words, when you integrate a rate function, you're calculating the amount of stuff that's accumulating, that you're adding up. So if we're measuring people per hour, then we're calculating the number of people. So what would you be finding? Since e of t is the rate at which people enter, you would be finding the number of people who enter the park between 9 o'clock and now 14 on a 24-hour clock would be 2 o'clock p.m. What units would I use? Well, the units would be people. I'm measuring the number of people because when I integrate a rate function, I go back to finding the amount of stuff. So if I'm integrating people per hour, I'm finding the amount of people. Similarly, what if you were to integrate the L function? Now, L told me it was the rate at which people were leaving. So in this scenario, this would be the number of people who leave the park between 9 a.m. and 2 p.m. And what units would I use? I would use people, because when I integrate a rate function, I calculate the amount of stuff. If I'm integrating people per hour, I calculate the number of people. In this scenario, how could you calculate the number of people in the park at 1 p.m.? Well, the number of people in the park are going to be the number of people who entered but then we have to take away the number of people who left. So how could we find the number of people who entered by 1 p.m.? We would integrate our entering function. We add up, integral, all of the people who enter, E. Now we can start at 9 a.m. because that's when the park opens. But then we have to end at 1 p.m., which we would call hour 13. We have to now take away the number of people who left. So the integral from 9 to 13, L of t dt. How many people came in minus how many people left. Now here's one catch. What if there were people there before anybody came in? So maybe employees come to the park and get everything set up before everybody else comes in. One of the things a lot of people forget is that we need to include the initial number of people and then add in how many people enter and then take away how many people left. So remember I said that this initial value was going to be really important? It is really important to know how many people were there before everybody started entering, because we need to add that number in to calculate how many people are there at any given time. There were 10 people there when we started. In general, and you're going to want to remember this, anytime you're asked to calculate the amount of something using the rate functions, it's always going to be the initial plus the integral of the in rate minus the integral of the out rate. Now, I don't care if you're calculating the number of people, the amount of gravel, the amount of grass clippings. It doesn't matter what you're calculating. You take how much did you start with plus how much came in minus how much came out. Let's look at some more examples. So, let's say I give you the exact same scenario. I literally just wrote it again on this page so you didn't have to keep flipping back and forth. And I said, the only change is that at t equals 9, there were no people in the park instead of 10 people in the park. Okay, so we've got people coming in, we've got people going out. It's still open from 9 to 23 hours, so 9 a.m. to 11 p.m. And at the beginning of the day, there was nobody there. So for part A, how many people have entered by 5 p.m.? So now let's actually do some calculations. So if I want to know just how many people entered, I'm going to integrate from 9 to 17 my entering function. Now to do this, I'm actually going to use my calculator. So one of the things we haven't talked a lot about, at least not in a long time, is that you can compute integrals. It's math option 9. So it's just below where you would compute derivatives, you would compute integrals, math 9 on your calculator. So I would integrate from 9 to 17, my entering function. Dx. And my answer would be, it says round your answers to the nearest whole number, which kind of makes sense. You're not going to have half of a person. My answer would be about 6,004 people. Now, if I want to know how many people left, or not how many people left, it says the price of admission is $15 until 5 p.m. After 5 p.m., the price of admission is only $11. It kind of makes sense. A lot of amusement parks, like if you're going to go in at the end of the day, the second half, you get charged less because you can't stay as long. How many dollars are collected on any given day? Round your answer to the nearest whole number. So we're going to collect money for all the people who come in. We're going to collect $15 per person times the people who enter before 5 p.m. Plus we're going to charge $11 a person for each person who enters after 5 o'clock. So I'm going to charge $15 times. Now how can I figure out how many people enter before 5? I would just integrate from 9 to 17 the people who enter the park rate. Because if I integrate the rate, I get the amount of stuff. Plus, I'm going to charge $11 for everybody who comes in after 5. So the integral from 17, and we're only open till 11, 23 of the people who enter. And again, I have a calculator, so I'm going to go ahead and type this in. So 15 times math option 9 is integrating, 9 to 17 of my e function. So 15600 divided by x squared minus 24x plus 160 dx plus $11 times math option 9 integral from 17 to 23 of 15600 divided by x squared minus 24x plus 160 dx, finish my parentheses, and it looks like I get about $104,048 and 17 cents. Okay. Now, again, same exact thing. I just retyped it so we didn't have to keep flipping back and forth to look at the equations. Let's let h of t be the integral from 9 to some number, wherever we decide to stop, of the e function minus the L function. The value of h of 17 is 3,725. What is the meaning of h of 17? Well, let's think about what we're doing to calculate h of 17. To find h of 17, we would be plugging in 17 for t. So in other words, h of 17 would be the integral from 9 to 17 of my e function minus my L function. So let's think about what that would calculate. We said that E was the rate at which people came in and L was the rate at which people go out. So if I integrate that, I'm calculating how many people come in minus how many people go out. Well, if I take how many people come in and I subtract how many people go out, then I'm calculating how many people there are now. What we call that is net change. So what we would say is that h of 17 would be equals 3,725 means that there are still 3,725 people in the park at 17, which translates to 5 o'clock. Because if you take how many people came in and you take away how many people go out, there's this many left. What does h prime of 17 mean? Well, just like here, I thought it was helpful to write out what this would be to help us interpret it. It's going to be helpful to write out what this would be to interpret it. So let's just start with h prime of t. H prime of t without the 17 plugged in would just be taking this t and plugging it in, because you're taking the derivative of an integral. So we would have e of t minus L of t. Well, e of t is how fast people enter. L of t is how fast people leave. It's the rate. So h of 17 would just be e of 17 minus L of 17. Now if we calculate that, because it does say find that number, all we're doing is taking 17 and plugging it into this equation. We're not actually taking the derivative or anything like that. We're just plugging it in because e is just the regular function. So I would have, let's see here, 15600 over 17 squared minus 24 times 17 plus 160 minus the L of t function, which would be 9890 over 17 squared minus 38 times 17 plus 370, which I'm going to make this a decimal. Why can't I make it a decimal? Math, there we go. Math, make it a decimal. Okay, I got negative 380.281. Now we're looking at people coming in at people per hour minus people leaving at people per hour. So the units on our answer would be people per hour. So we're looking at how fast are people coming in and how fast are people going out. Well, it looks like we got a negative answer. So people are leaving faster than they're coming in. So I would say the rate at which people are coming in is negative. In other words, more people are leaving. So how would I interpret this? The number of people in the park is decreasing, because I got a negative number, at a rate of 380.281 people per hour at 5 o'clock. And the reason it's the number of people is decreasing is because these are the rates at which people are coming in and leaving. So decreasing means I ended up with a negative rate. At what time does the model predict that the number of people has a maximum? Now the number of people are going to have a maximum when the rate is equal to 0 or at the endpoints. So a maximum is going to occur when E of t, the rate going in, minus L of t, the rate going out, equals 0. Normally we would just say when the derivative equals 0, but these are both derivatives that are affecting this amount. There's the in and the out. So how do I figure out where this happens? Well, one way to do this would be to graph e of t minus L of t and find the zeros. So let's try that. So I would go to my y equals, and I would graph 15600 over x squared minus 24x plus 160 minus alpha y equals 9890 over x squared minus 38x plus 370. Now I know that my x values have to go between 9 and 23, so I'm going to set my window to 9 to 23, and then I'm going to look for the x values. It looks like I have 1 0 right there. So I would calculate my 0, which is between 9 and 23, which would be 15.795. However, we also know that a maximum could occur at the endpoints. So just like when we were doing our problems previously, we're now going to look for an options chart. So our options chart is going to be, so first we make the derivative equal to 0, only now there's a derivative in and a derivative out. Then we make an options chart. When t is 9 is the beginning, 15.795 is the number I calculated, and 23 is the other endpoint. And we need to calculate the number of people in the park. Now we said the number of people is going to be the initial plus the integral of the rate in minus the integral of the rate out. So, how many people did we start with? Well, we changed this one a little bit to make our lives a little bit easier. At t equals 9, there were no people in the park. So in this problem, the initial is just 0, but a lot of time the initial is not 0. Plus the integral of the rate in minus the integral of the rate out. And we're going from our original value, which is 9, that's when we're starting, our initial value, to what we're trying to figure out now, which is what's happening at 9. Well, in this case, I'm not even going to bother typing this into my calculator because these are both going to be zeros, so the answer is going to be 0. There's nobody in the park when it opens. To calculate how many people are there at 15.795, you would do 0 plus the integral and you would still start at 9 because that's when the park opens, but you would end at 15.795 because now we're interested in how many people there are at that time. So I would go to my calculator and I would say 0 plus math option 9, the integral from 9 to 15.795 of the people going in, which is 15600, over x squared minus 24x plus 160, minus the integral, math 9, from 9 to 15.795, and I have 9890 over x squared minus 38x plus 370 dx. And it looks like this answer is 3,950.680. And finally, I would do the same thing for 23. So initial plus the integral of people coming in, the rate at which people come in, and the rate at which people go out, starting from 9 a.m., ending this time at 23. I'm actually just going to go back to what I just typed in, and I'm just going to change all the 15.795s to 23. and I'm going to get 1.013. So when are we going to have the maximum number of people in the park? Well, this is the biggest number on my list. So at hour 15, which would be a maximum number of people. All right, we are going to go ahead and stop there. We will do some more examples in class for practice. I hope that what you want to walk away with today, so maybe somewhere in the back of your notes that you just have this, what you want to walk away with today is that for problems where they give you rate functions, if you integrate a rate, you get the change in the stuff. So in other words, if you integrate the rate at which people enter, you get how many people enter. If you want to calculate the new amount of stuff, so in other words, how many people are there now? You always do the initial plus the integral from whatever initial time you had of the rate coming in minus the integral from the initial time of the rate going out. All right, guys, thank you so much for watching, and I will see you for some practice. Have a good night.